Okay, so this is an arithmetic sequence versus an arithmetic series. So sequence was separated by commas. Oh, try it again. Each term is separated by commas. Whereas in a series, we're going to be separated by plus or minus signs. Okay, because we are actually, instead of just having a sequence, we are going to add the terms together. S of n is the sum of the first n terms. So if I'm asking for S of 5, that's the sum of the first 5 terms. Okay? This little 5, the little subscript, is your n value. Okay, so if I wanted to actually find S5 in the sequence above, I would have to add 1, the first term, the second term, the third, fourth, and fifth together. One, 3, 5, 7, and 9. That adds to 25. Okay, so as long as it's only asking for like a very small sum, S4, S3, right, that's easy to do. If I ask for the sum of the first 100 terms, that's going to take a while if you wanted to do it manually. For this sequence here, let's figure out the general term. Do you remember what the general term is? The equation. We want the equation. That's the formula, right? Or equation. And it's always T of n. T of n equals. So that's just a general formula or general equation for the sequence. So let's plug it into the formula. What's term 1? 3 plus n minus 1. You're going to leave it as n because we want to make the formula. And what's our common difference? 4. And so this will simplify to 4n minus 1. When you distribute this in, you get a minus 4 and then subtract 1. I'll just write that. So finding S4, how would I get S4? 3 plus 7 plus 11 plus 15, which gives me 10 plus 26 is 36. Okay, I want you to find S8. So figure out all 8 terms and add them together. What did that add to? Should we figure it out? 136. So fine, right? Like that's fine if you're only looking for S for a small sum. It's completely fine just to do it manually. But if I ask for a large sum, we need a formula to do that. It can be very cumbersome if I'm asking for S100, the first sum of the 100 terms, right? Very cumbersome. So we're going to derive a formula. So what we're going to do is say this is, sorry, I should have changed this to plus signs. Say this is, how many terms is that? 7? S7 for some sequence. Okay? 2 plus 5 plus 8 plus 11 plus 14. I wanted to find S7. So I'm going to show you how the formula was developed. So what we're going to do is I'm going to write, again, the same sum, but let's write it backwards. So instead of term 1 to term 7, let's write term 7 to term 1. So 20 plus 17. Try and make them line up with the terms above them. 14, 11, 8, 5, and 2. Same sequence but backwards. So what this does, we write that down. What we're going to do is we're going to add these two equations together. And you've done that, right? When you did systems of equations before, you've added equations together. So let's add these two equations. So f7 plus f7, if you add 2x plus x together, what does that give you? 2x's, right? So f7 plus f7 gives me 2 f7's. Now notice, if we add vertically each one of these, what do they add to? Every single time. 22. 22 plus 22 plus 22 plus 22, 2 plus 22. Okay, is there an easier way to write that? If we're adding 22 together 7 times. 7 times 22. So 1/2. 7 times, oh, sorry, don't put the 1/2 there. That's not right. I'm ahead of myself. 7 times 22. Okay, now we want S7 by itself, so this is where there's 2 S7s. How do I get rid of the 2? Divide both sides by 2. Okay, so I'm just going to rewrite this here. S7 is equal to, instead of 7 times 22 divided by 2, we could also write that as 1/2 times 7, or 7 times 22. Right? If you timesing by half is the same as dividing by 2. So what does that mean? Like, you're like, okay, well, I still don't understand why you're doing this. Well, in this question, how does the 7 relate to us? There's 7 terms. That's the number of terms. Okay. What's the 22? Well, the 22 was term 1 plus term n, the last term, the first term and the last term added together. It's also the second and the second last term added together. It's also the third term and the third last term added together, and so forth. So the easiest thing for us would be the first term plus the last term. First term plus last term. Okay, is there, so what do we represent first term with? T of 1. How do we write the last term? T of n. Okay, and then this was multiplied. That was the 22. 7 was the number of terms. What variable is the number of terms? N. We had a 1/2. And that was equal to S of n. So that's our very first formula. Now it looks a little bit different. We'll put the n and the 1/2 together. So instead of writing 1/2 times n, we'll write it as n divided by 2 times term 1 plus t of n. So if you look on your formula sheet, whoops, where are you? There it is right here. See it? Okay, so that's that first formula that we derived. The second one's really easy to get if you already have the first formula. So there's 2 formulas here. I'm just going to zoom out a bit. Okay. So the one we just derived is the very first one. So what do we need to know? We need to know our first term, our last term, and the number of terms. We do not need to know the common difference. As you can see, there's no d in that formula. So we just need to know term 1, t of n, and n. Do not need to know. So this is the easiest formula. If you look at the next one, it's not as easy looking, right? Looks a little bit more complicated than the first. it's really easy to derive the second formula. So say you know your first term, just like the first formula. You know your number of terms, but you don't know your last term. Instead, you know your common difference. So this formula here, you don't have to write this down, but I can just show you really quickly how it was derived. So that very first formula, say I didn't know my last term. Is there a formula we have for t of n, the last term? Yeah, that's the very first formula that we did yesterday and the day before. T of n is equal to term 1 plus n minus 1 times d, right? This is the formula on your formula sheet for T of n. And so that's how we get two term 1s, because term 1 plus term 1 gives you two term 1s plus n minus 1 times d. So it's really just inputting that first formula for the last term, and that's the two formulas. Okay? So really it's the same thing, right? It's just derived from this formula and using the T of n formula. Okay, so let's give them a whirl. Just find the sum of the first 45 terms in the sequence. So tell me what I know. Term 1 is 30, good. What else do I know? S45 is what we're looking for. That's our unknown, right? We're trying to find the sum of the first 45 terms. So that means if we're looking for S45, that tells me what? Yeah, n is 45. Do we know anything else? We don't. We do. We know our last term, which is good, because if we can use the first formula, that's great. It's a lot easier. The very first sum formula is a lot easier. We don't even need to worry about knowing our common difference, even though we do know it. We don't need to worry about it. So the formula is the sum of the n terms equals n over 2 times term 1 plus term n. First term plus last term. So let's do it. S45 equals, n is 45 divided by 2 times 30 plus and last term negative 190. The nice thing about this formula too, it's kind of like hard to mess up typing it in. 30 plus negative 190. Okay. So you get the same thing, negative 3,600. Yeah. That's what you should get. All right. The second guy, the sum of the first 21 terms in this sequence. So let's list what we know. We know what? We know T1 is negative 11. What else do we know? N is 21. We're looking for S21. So we want the sum. That's our unknown. And do we know our last term? No. So we're going to have to use a second formula. We do. Could we figure out our common difference? What is it? What are we adding each time? Close. Plus 4. Okay. So there we go. There's our as long as we know the first term, common difference, and the number of terms we want to add together, we can now use the second formula. So n over 2 times 2 times term 1 plus n minus 1 times d. And that would sum those 21 terms together for us. 21 divided by 2. 2 times negative 11 plus 21 minus 1 and multiplied by 4. You might want to simplify inside those brackets first, or we could type it in all at once. 2 times, I don't really need brackets in the calculator when I'm doing multiplication. 2 times negative 11 plus, now here's where you'd want brackets, but like 21 minus 1 we could just do in our head too, right? It's 20 times 4. If you want to put brackets and go to 21 minus 1 and then times 4, you're welcome to, but you don't have to. And then enter. So I could have also entered bracket 21 minus 1 times 4, like that. 609. Okay, find the sum of the arithmetic series. 5, 9, 13, and 201. Okay, so this is technically our last question. I'm not sure if I'll add another one, but I might leave it here. What do I know? Okay, term 1. T of n, the last term. Common difference, which is, we're adding 4. Okay, and that's all we know, right? Notice that for the formulas that were here, both of them require us to know what value. So both of them say you have to know your first term, and both formulas in order to use them, you need to know n, the number of terms. We do not know n. That's a problem. Exactly. So, unknown. Okay, we always need to know how many terms, or n, to find a sum of an arithmetic series. So that's where we have to go back to our skills from the previous days and the original formula. We have to figure out what term number is 201. How many terms are in this sequence? We know our last term, so we can figure out n, right? But we have to go back to this formula before we can use the sum formula. Okay, so last term was 201 equals the first term, 5 plus n minus 1 times our common difference of 4. So go ahead and solve for n here. Okay, you get 50. Good. So now we can find the sum. It's really up to us to which formula we want to use. We can use either or. So let's use the easier one because we do know our last term. So why not use first term plus last term times n over 2. Okay, so the sum of the 50 terms, 50 over 2, 5 plus 201. Gives us 5,150. Okay. Just a little side note. I was going to talk about this more when we do geometric series, but I think I should talk briefly about it now, just so you can start getting your head around it. So you know that S1 is the same thing as term 1, right? If you're only adding one term together, it's the same thing. Agreed? S2 is term 1 plus term 2. Okay? So if you know two sums, two consecutive sums, you can actually figure out one of the terms. Okay? So what I mean by that is term 2 is equal to the sum of the first two terms minus the sum of the one term. Like, why is that? Well, we know S2 is the first two terms added together. S1 is the first term. So if I subtract that, what are we left with? We're just left with the term 1's cancel. So we're just left with T2, right? And so this idea, if we know two consecutive terms, we can actually know a term number. So if I look at more, like if I look at, say, if I know the sum of the first three terms and the sum of the first four terms. So S3 is term 1 plus term 2 plus term 3 plus term 4. Nope. Ahead of myself. Just three terms. And this guy is all four. Right? So the subtraction, what would be S4 minus S3? If I subtract those, what would I be left with? T4. The fourth term would be S4 minus S3. And so if you're given two consecutive sums, the difference is the larger term number, right? Because that, if I subtract these off, I'll show you here, T4 minus term 1 plus term 2 plus term 3, term 1's cancel, term 2's cancels, term 3's cancels, and we're left with term 4 as the only thing left over. Okay, so just on a side note, like a question they might say is like, if S4 is 73 and if S3 was 50, what's term 4 then? $23. 73 minus 50, two sums, so 23. Okay. And so what I could do is, often what will happen is a test question is they might give you like some more sums. Anyways, and then you have to figure out the common difference. So then if you know this sum and this sum, so let's say this was 100. Okay, so then what would be term 5? Well, term 5 would be S5 minus S4. You can, when you subtract those consecutive sums, so in this case would be 100 minus 73, or that equals 27. So now you know the common difference, right? In the sequence, the common difference is 4. So the term 4 is 23, term 4, 5. It's a little bit of a tough concept to get your head around it, and we'll do more questions coming up, more so in geometric stuff, but I just kind of wanted to introduce you to that idea today. Okay? So that's it for the lesson. Your assignment is page 27 to 31, 1 to 4 A and D, 5 AB, 6 AD, 8, 10, 11 is a starred question. Tough one. You can try it though. Okay. And then you get Monday off school. You know that, right? Monday's a PD day. So we'll go through this on Tuesday some more. And then your quiz is going to be on Thursday next week. Thursday, February 9th. So we have a lesson on Tuesday and a lesson on Wednesday. And then your quiz is on Tuesday. Yay! Welcome back to school.